Module 4, Section 4, we will discuss the slope and rate of change. To start, let's define the slope of a line. The slope, which is always represented by the letter M in this course, the slope of a line containing the points x1, y1, and x2, y2 is given by the following formula. Let me note that these 1s and 2s are not exponents. They are just labels. It lets us know we have a first x-coordinate and a second x-coordinate, a first y-coordinate, and a second y-coordinate. It'd be a great thing for you to write this equation, the slope formula, in your notes. So let's get right into it. Let's find the slope of a line that goes through the points 4, -3, and 2, 2. Let's start by labeling the points. Let's label the first x-coordinate x1, the first y-coordinate y1, the second x-coordinate x2, the second y-coordinate y2. Once we have labeled, we're going to write the equation to find slope. M equals y2 minus y1 over x2 minus x1. Since we've already labeled our points, we simply substitute them into the formula. Y2 was 2, so we have 2 minus -3 over 2 minus 4. Remember, when we subtract a negative, that's like adding a positive. So 2 minus -3 is 2 plus 3. 2 minus 4 would be -2. We continue to simplify. 2 plus 3 is 5. So we have 5 over -2, which is the same as -5/2. Let's try another example. Let's find the slope of the line that goes through 9, 2 and -9, 2. Again, we start by labeling our ordered pairs, x1, y1, x2, y2. Once we have labeled, we write the slope formula again. M equals y2 minus y1 over x2 minus x1. Plugging in the information we just labeled, 2 minus 2, all divided by -9 minus 9. In the numerator, 2 minus 2 is 0. In the denominator, -9 minus 9 is -18. Remember, it is okay to have 0 in the numerator. 0 divided by any non-zero number is simply 0. So the slope in this case is 0. Let's try a third example. Let's find the slope of the line through the points 1, 2, and 1, 3. Starting the same way, we label our 2 points. Now here I will mention that it's okay to label your points differently. You could have labeled the first point x2, y2, and the second point x1, y1. If for some reason you chose to do that, that would be completely up to you. You would still get the same exact answer. So now that we have labeled, let's write our slope formula. M equals y2 minus y1 over x2 minus x1. Plugging in the information we just labeled, 3 minus 2 over 1 minus 1. In the numerator, 3 minus 2 is 1. In the denominator, 1 minus 1 is 0. This is a problem. Anytime we divide by 0, we say that the given fraction is undefined. So here we would say the slope is undefined. And the slope, if we are given the line for the equation, and in this case 2 points are singled out. We already have 2 points we're looking at. Instead of finding the coordinate values and the ordered pair values for those 2 points, let's use another piece of information that showed up along with the original definition. The slope can be considered the rise or the change in the vertical value over the run. The slope is the overall steepness of a line. So the rise, think of this as values going up or down, run, values going right or left. Starting with any point on this graph, let's start with the point 0, -5, and let's figure out how many we need to move up and to the right to get to the next point. So starting at 0, -5, we go 1, 2. So the vertical change is 2. The horizontal change is 1, 2, 3. So we see horizontally, or to the right, we go 3. So if we use this definition, that slope equals rise over run. The rise, the amount that we had to go vertically to get to the next point, was 2. The run, the amount we changed horizontally, was 3. So the slope in this case, which we always represent with the letter M, equals 2 over 3, or 2/3. Now, if you wanted to go through the process of labeling 2 points, finding their ordered pairs, and then plugging those into the slope formula, you could do that. And this way is much faster if you will remember that slope is rise over run. I've already mentioned this. When finding slope, it makes no difference which point is identified as x1, y1, and which point is identified as x2, y2. Just remember that whatever y value is first, its corresponding x value must be first in the denominator. Here are just a few clues that will help you remember what kinds of slopes you have. A line with a positive slope increases. The line goes up from the left to the right. A negative slope goes downwards from the left to the right. Let's now try to find the slope of an equation. So here we are neither given 2 points or the graph, we are actually given the equation. If I want to find the slope of an equation, first we need to introduce a new form of an equation, which is slope-intercept form. Slope-intercept form looks like this. Y equals mx plus b, where b represents the y-intercept. Remember, that's where our equation goes across the y-axis. And m, hopefully you remember this, always represents the slope. Essentially, slope-intercept form tells us this. We want to solve our equation for y. And when our equation is solved for y, whatever number is in front of x will be our slope. So let's see if we can do that. We started with -6x minus 5y equals 8. We start by isolating 5y. So we move 6x to the other side. The opposite 6x's cancel. And we're left with -5y equals 6x plus 8. Now we haven't quite solved for y yet. It's still being multiplied by -5. So we divide both sides of the equation by -5. And I'm going to divide every term because that means the exact same thing. So the -5's cancel on the left-hand side. We're left with y equals -6/5 x. And because we have a positive 8 being divided by -5, that would be a negative fraction, or -8/5. Now what we have done is we have solved for y. And so matching our equation with slope-intercept form, which we wrote at the top of the page, in place of m, we have -6/5. So we can say that m equals -6/5. And remember, m is the slope. So we've now found the slope of the equation without doing too much work. Let's try another example. Find the slope of the line y equals 1. In this particular situation, we only have one variable. So this is different from the last time. Last time we had an x quantity, we had a y quantity, and we were able to use the slope-intercept form. When we have one variable, we can know right away that the slope is going to equal one of two things. The slope will equal 0, or the slope is undefined. Here's how we know. The slope will be 0 if we have y equals a number. The slope will be undefined if we have x equals a number. Remember that this is the case where we only have one variable. And so if you have x and y in the original equation, this won't work. But since we started with one variable, and that variable was y, the slope, m, will equal 0. And this will always be true. So remember, for any 2 points, the y values will be equal to the same real number if we have a horizontal line. The numerator in the slope formula would be 0, but the denominator would not be 0, and therefore we would have a 0 slope. So just remember, horizontal lines always have an equation, y equals a number, and they always have a slope of 0. Vertical lines always have the equation, x equals a number, and they always have a slope that is undefined. If we can define slope as steepness, then think of a vertical line like being a wall. A wall has a steepness we can't climb. We could say a hill is steep. We might say a sidewalk is steep if we're going up a hill or down a hill. But we wouldn't say a wall is steep. A wall is something we don't typically climb. So something that has a straight up and down line, a vertical line, its slope would be undefined. Now, while we're talking about slope, it makes sense to discuss parallel and perpendicular. So if we say we have two lines that never intersect, those are called parallel lines. Parallel lines never intersect, so something like railroad tracks, we could think of each track in railroad tracks as being parallel lines. They never intersect because they have the same slope. Perpendicular lines are lines that intersect at right angles. You might think of an intersection. Two non-vertical perpendicular lines have slopes that are called negative reciprocals. Remember, the reciprocal is when we flipped a fraction. Negative, we would change the sign. And if we multiplied two perpendicular slopes together, the product, the result would be -1. It's also very important to remember that horizontal lines and vertical lines are perpendicular to each other. So let's try one example. Let's find the slope of a line perpendicular to the line passing through -1, 3 and 2, -8. So we see perpendicular. Well, it doesn't matter what word we have. The first step is to find the slope. Using the information that was given. In this case, we had 2 points. So to find the slope, we go through the process of labeling x1, y1, x2, y2. We then write the slope formula. M equals y2 minus y1 over x2 minus x1. Since we've already labeled, we plug in. We have -8 minus 3, which is -11. 2 minus -1, which is the same thing as 2 plus 1. So this becomes -11 over 3. Now that's not the final step if we have that keyword perpendicular or parallel. When we see perpendicular, we have to do one more thing, and that is find the negative reciprocal. Let's start with the reciprocal. If we have 11 over 3, that would change to 3 over 11. Negative more or less means we're going to change the sign. So since we started with a negative fraction, we want a positive fraction. Or we can write it without the positive sign. So the slope that is perpendicular to the original line would be 3/11. Let's also work an example with parallel lines. Let's find the slope of a line parallel to the line passing through 0, 3 and 6, 0. So again, we have the keyword parallel. It could have just as easily been perpendicular. We go through the same process. First, we find the slope. To find the slope, we first label our points, x1, y1, x2, y2. We then write the slope formula, m equals y2 minus y1 all over x2 minus x1. We plug in our labeled values, 0 minus 3 all over 6 minus 0. The numerator gives us -3. The denominator gives us 6. And in this particular example, we can simplify the fraction. It will reduce to -1/2. Now, because we have that operator word parallel, just like if we would have had perpendicular, we need to do something else. We need to make sure we go through the process of finding the correct slope. Remember, parallel lines have the same slope. So whatever slope we find gets to stay exactly the same. For parallel lines, we actually do a little bit less work. So make sure you work hard. It's easy to lose your signs when you're using the slope formula, so be careful when you have negatives.